Hi, welcome to, hi, I'm Rashmi.
Hi, this is Haruna.
Hi, welcome to session 6 of the BPS Summer Coding Series of Sampler. Today's session is Introduction to Code Studio and other Code.org courses. Give me a quick second. I'm going to go to our slides. Okay. So welcome again to the session 6 of BPS Summer Coding Sampler. We'll be talking about some of the courses offered by Code Studio, doing some activities with the courses, and then sort of an overview of what's being offered. Logistics, again, all of our resources are hosted in BPS Learns. So let's quickly go there. So this is the session for today. We have our webinar. Before the webinar, I asked people to create, to create their account, but if you haven't already, it's okay. You could always look at the webinar and then go in and do some of the activities. This is a YouTube link. Please tune into today's Meet live link to give us feedback or if you have questions. Exit tickets, response prompts, and other activities are posted here, and we'll talk about it as we get into the homework section. Just quickly, yeah.
Make this wider.
Oh, okay. Sure. Excellent.
Yeah, that's probably
Yeah,
better.
that's good. Thank you very much. So quickly, just make sure you are viewing the webinars and doing the assignments in time so that you are on track for getting your PDPs. You can always watch all the videos that are being uploaded with this sampler series. They are on the DLT channel, YouTube channel, and we have a playlist right there. Today's session agenda is, of course, the whole discussion is focused on, access to computer science for all, with equity being the center of it, sort of making sure that we are getting access to students where they need it, when they need it. We'll talk about what is Code.org, what are the curriculum options you have on Code.org. We'll frame it in the context of, elementary, middle, and high school as the courses are offered. We'll talk about some curriculums, assessments, resources, the different standards that are being integrated with this curriculum so that it's, it connects really well with CSTA, MADLCS standards, and we'll talk a little bit more about that. Code Studio CS Principal course is going live this year, and it was also AP approved, so we'll talk about that. And then lastly, we'll talk about the homework, assignments, and a Go Beyond assignment. Moving on. What is Code.org? So Code.org was launched in 2013. It is a nonprofit which is dedicated to expanding access to computer science and increasing participation of women and underrepresented students of color. The vision is simple, very powerful. It's essentially every student in every school globally should have an opportunity to learn computer science and to make computer science part of the core curriculum. Code Studio is their online, let me quickly switch. So Code Studio is their online platform, and most of the CS fundamentals and part of other courses, curriculums are implemented within Code Studio. So that's where the Code.org is. Give me a quick second. We're going to talk a little bit about the Code.org's privacy principles. They take it very, it's very important to them. It's sort of recognizing that they create a safe and learning environment, and they take the protection of information very seriously. Their important disclaimer is that any student's academic data provided by school, district partners, or any third party partners is essentially used for evaluating purposes. So for example, if data is given in for a CS Principles course, that is to make the course better, that serves as a feedback. The data is always stated as anonymous or de-identified, so it's not really shared with anyone for financial gain purposes. They do not sell personal information or have any ads on their site, so you can see that the information is safe. They also do not require, Code.org does not require to provide personal information. Most of the tutorials are available to you without a user ID. So if you feel safer that way, you can always do that. And we just wanted to reemphasize this because their disclaimer states that you as the educator or the student will always have access to and control over the information that's being shared. So this is quickly the privacy policy. And this is where they've stated it very clearly how the collection and use of the information that they gather is being presented. So just to kind of go over it and making sure that we are addressing the privacy concerns. In BPS, we have a digital backpack, and we'll talk about it at the end as to how you can access Code.org through that, and you can also manage student information and student registration through that. Quickly getting back to the slides. So let's quickly go to Code.org. So they have done a really good job in terms of contextualizing their curriculums or materials in in the and the resources that are being organized with the inherent built-in flexibility about access and usage to curriculum. It really helps in seeing how this curriculum is offered at different levels. So we'll first go to the elementary schools and what is being offered. So let me quickly go there. For elementary, the Code.org K5 courses blend online, self-guided, and self-paced tutorials with unplugged activities that require no computer at all. Even kindergartners aged and pre-readers can participate in some of these activities. And if you see the computer science fundamentals curriculum, that's how they state it. It's the curriculum that includes course 1, course 2, course 3, and course 4 from Code Studio. The Code Studio is their online platform, and this completely free curriculum sort of consists of different activities at different levels that can be introduced to the students. But as a course also, you can introduce computer science fundamentals into the classroom. So let's go to quick overview of computer science fundamentals. I just wanted to show you that. There is a quick one-pager about who should take it, who made this. So there are a lot of partners in making computer science fundamentals and that Code Studio courses. I really want to mention, Common Sense Media is also part of developing this exciting, engaging curriculum. Who is it for? They've talked about, which courses for what age. So, these are recommendations, of course. If your students are going beyond these age levels, you can always transfer to the next course. The course structure is really interesting, and they have, if you see the online experiences are composed of mostly self-guided, self-paced tutorials, but they have a lot of integration of hands-on and kinesthetic approach built into the activities. So they have a lot of unplugged activities that you can use, physical manipulatives and models. Each sort of course consists of 18 to 22 lessons. The most important part in terms of standards alignment is it is aligned to the CSTA computer science standards and ISTE standards. So CSTA computer science standards are nationally recognized. And we'll talk about MADLCS standards and how they connect with that. So it's a really well-aligned curriculum that sort of addresses a lot of really great topics such as algorithms, understanding of algorithms, loops, functions, variables, so on and so forth. And then sort of also addresses these computational thinking practices of creativity, collaboration, communication, persistence, and problem solving. So without further ado, give me a quick second and we are going to go to the Code.org course 1. So we can do some fun activities. Where did I put it? I think it's right here. I think so. Yeah. Okay, so that's your course 1. Again, course 1 is meant for early readers, so you're looking at ages 4 to 6. There is no prerequisite, and topics include internet safety, sequences, loops, events, and focus on fostering sort of meaningful collaborations with kids. So let's look at the first activity. There are unplugged activities in here, but before that, let me scroll down quickly and show you what it means to have these, green circles with filled up check marks. So 1 means it's not started, you have not started the activity. The yellow circle means it's in progress, completed, but not too many blocks. So they give you feedback in terms of if your programming has too many blocks or not too many blocks, then completed, perfect. And then the ones which have these blue circles around them, they are the assessments for that course. So I've done a few, so I'm going to quickly go and choose maybe.
Just let me.
Yeah, go ahead.
So this is the interface that the students will see once they log into Code Studio. But then you're going to have your own teacher interface if you're managing the class in Code Studio. And in the teacher interface, you'll see a kind of a simplified view of this with all the students listed. So you won't see a separate page for each student. And you'll see like the whole class in one page and you'll be able to track where along this stage the students are.
Yes, we could show you the teacher dashboard, but right now, it's sort of, we don't have any students in there, so you may not be able to see the data, but it's sort of, there is an image as to how it looks like for you. So we are going to quickly look at the very first activity. I wanted to see if this plays, so let me see. We're working with our internet connection, so let's see. This is a really nice, they have an integration of videos and activities within this, but should I play this?
Yeah.
Yeah, let's see.
This lesson is called Happy Maps. Today we're going to help our furry little friend, the flurb, get to her fruit.
Make your flurb go to your fruit.
To do this, you'll need to figure out which way the flurb needs to go and direct her with arrows. In order for the flurb to get to the apple, what direction does the flurb have to go?
Mine, make it go up. And to get it there, you circle the direction that it has to go.
Create your algorithm by gluing arrows next to the map that you're trying to solve.
And the second one, it's the same, but it's going down.
It's like programming with paper.
And that's it.
That's a really great activity, and you have a nice little lesson plan, and you can download the PDF for it. You also get the cutouts for these arrows, and you can possibly, we have some fun activity going on outside. Okay, so you can use the resources provided to do this activity. And it's a really fun little activity to introduce them to. There is also, I'll show you the lesson plan and sort of aligned objectives in terms of, the learning objectives in terms of standards. But I wanted to also show you this quick activity. So you have sort of a challenge where it says which arrow gets the flurb to the treasure. So you have your flurb right here and you have your treasure. So let's see, he has students go through this iteration. Is he moving this way, so or this way, and they arrive at it. It's chosen and get this really loud sound. So you might have to mute the computers at this stage if you kind of keep on hearing this sound with 20 students. So your answer is correct. We go back. I wanted to show you, it sort of automatically goes to the next activity, and you can see there is another unplugged activity with the lesson plan and downloaded PDF that you can use. But let's quickly go back. And the second activity I wanted to show you was this one. So I sort of went at the end so that I could look at the assessment. So this says, Jigsaw learn to drag and drop. And in this activity, you can see that they have a challenge where it says arrange the blocks to form the image. So I'm going to click on that. And it's a neatly, you have sort of your workspace, you have your blocks right here. And I'm going to go in here and sort of organize my blocks with an understanding of, I'm looking at the colors, what goes in first. Also, sometimes when the students come in, you may have to explain to them that, the notches go in right here, and there is that clicking sound which allows for that block to fit in. The second block is the blue block, and then you have the color-coded green block. And again, you get that. I don't know. So if you continue, you will see, you will see the next one. So if you go through activities 1 to, say, in this case 11, you will see that there is an incremental level of complexity that they have added to the activities, and it seamlessly flows from 1 to 11. So students are gaining certain skills as they go through these activities. So we are going to say continue.
And this particular one is for age 4 and up. So it's for pre-K and kindergarten students. So this would be their first time maybe even trying dragging and dropping.
Right.
So this is a very nice way to kind of play a little game to learn how to drag and drop on a trackpad.
Absolutely.
And also, having the little puzzle, which as if you have done Scratch, you might notice that it looks pretty familiar.
Yes.
They're getting used to that visual interface of these block coding.
Absolutely. So another puzzle, and as Runa mentioned, it's very important that they sort of get a handle of, where they're dropping, so you can drag, so the whole thing gets dragged, so then they understand that maybe eventually, you are trying to move one block at a time, and then that's the head, so I'm going to place it. Can I still move it? No. So I'm going to take the second block. I'm going to try to move it. That's my third piece, and then you get that sound. So you can continue. It's a nice celebration that you've put together the puzzle, but it's also, as Runa mentioned, it's giving you that practice of block programming, how to be working with blocks and block programming. So that's a great little learning tool. So one more, maybe from course 1. It is very addictive. Give me a quick, maybe
yes,
we can
each of this activity only takes a few minutes. So it's like reading one of those books with very short chapters. You just keep on doing it. Oh, a little bit more. Oh, let me do the little one, a little bit more. And it is pretty addictive.
Yes, and they're really great activities, and students are very excited about doing and learning at the same time from these activities. So let's, I'm going to quickly go back to, let me see. I looked at like real life algorithm. Oh, yeah, this one. Yeah, more. This one.
Yep, that'll show you the entire thing.
Yeah, so let's look at, I was thinking of doing the real life algorithm, which will be, I think, right here. Okay. So let's see what the unplugged activities for that. And it's a really nice integration with, what they're doing in science classroom probably. So let's watch that.
This lesson is called Planting a Seed, and it's going to help us understand algorithms. Algorithms are specific instructions that explain the order in which to do something. Even everyday things like eating breakfast or brushing your teeth are algorithms. They require small steps to get a job done. Computers can be really smart, but they can only understand you if you tell them exactly what you want, step by step. The great thing about algorithms is that if you follow the instructions in order, you can do something that you didn't know how to do ahead of time. It's like following a recipe. Today, we're going to plant our own seeds using an algorithm.
So first we have to fill the pot with soil, right? Well, I don't think we have to put glue on the seed. Right.
Create your own algorithm by cutting apart the pictures. Select the pictures that show steps in planting a seed, and then arrange those pictures in the correct order. Now, it's time for you to see if your algorithm works. Follow the steps in the algorithm very carefully. Are they in the correct order? Did you succeed in planting a seed by following the algorithm? It's like programming with pictures. When we want to make chocolate, there are many big steps to that process, and each of those big steps has its own set of smaller steps. And there are different recipes or algorithms depending on how we want the chocolate to taste. Each step is important, even the small ones. So without one step, the rest of them cannot be completed. Creating algorithms that others can understand is really important. That's why each step has to be written down, so no matter who does it, the result is the same.
These are really cool nuggets of information, talking about algorithms, and as you can see, they're using paper. They're kinesthetically interacting with making an algorithm as a process, as steps. So that's a really wonderful activity, and you can again have all the resources right here. You can download the PDF and should be able to use those activities in the classroom. Haruna, you want to add? We good? Okay. So we'll move on to the next activity in this series, which is, let me see. Okay. So it says multiple choice. Which step should go at the beginning of this algorithm? So sort of looking at this algorithm and what would be the step that needs, can it be this? So, sort of using the process of elimination, will it be this? Can it be put foot in the shoe? And it is dirty teeth. That's why you are putting paste on the brush, brushing the teeth, clean teeth. So you choose that, submit. There's no way I can. Okay, so let's look at, they have another multiple choice. In this case, you might have to point out how students are working with the multiple choice and sort of pointing out that it's also a process of elimination, being able to read that question that much clearly, because sometimes, you have like a, we'll actually look at an example at a later stage where the question is tricky. So, the obvious answers are, that the students would choose may not work out. So making sure that you're reading the question, reading what information is provided to you. So which step should fill in the blank for this algorithm? So let's look at the algorithm. We are filling the pot with soil, poke hole in soil, put seed in the hole, and then do we want to cover seed with soil or do we want to water the pot? Looks like we have water the pot. So then sort of we cannot use brush teeth. So again, process of elimination. So we have that, we submit. And what we just did is we completed an assignment that was, I'm going to stop this. Do I have that in here? I don't, but these are so addictive. Oh, I'm going to stop this one for a second. But doing these activities one after the other for you as an educator is also really very interesting because you're sort of going through increasing levels of different concepts and they're fun. So I'm going to quickly go to one that I wanted to introduce because I'm going to come back to the B at some stage. Artist shapes. So I wonder, okay. So we're going to take a look at artist shape, which is one activity. And the first activity in here is it allows you to draw a square below the triangle. So it has very specific instructions about, what they want you to do or what the challenge is. Let's say, okay. It gives you, oh, sorry. I think I should just do that. Okay. So he's standing here. That's my artist. And he has to move. If you see in here, I have, he wants to move in the forward direction. So I'm going to place that. And my inclination would be, okay, so I've covered that part of the square. Then I'm going to go down to draw the square. So I do that. Then I go left. So let's put that in. And then I go up. And you would think, okay, here is something that I've constructed and this looks great and maybe I should run it. And if I do, let's see what happens. It drew a square, but it didn't really do what I was supposed to be doing, or I didn't really do the challenge correctly. So let's see what happened. It looks like it took only half of that, half of the length. It drew only half of the length and then completed the square. So then it's a great discussion with the students, what could be done. And, so this is a great opportunity for having those questions built in. And eventually, as you go through it, they'll try and they'll understand, okay, so this is drawing half of it, so I need one more in order to complete that length. So let's put that in here. Then same goes with going down, and then same goes with going left, and then going up. And I hope we have to reset it always. So if you have a program that didn't work, we're going to reset it, and then with our program, with our new program, we're going to run it. And sometimes you get this, congratulations, you completed your puzzles. It gives you 8 lines of code. And it also gives you this option of show code. What this does, it gives you literally this block. What you're doing, the programming is in block-based, but this is your text-based code version of that block-based. So you can actually see the JavaScript option.
You can. It's really useful if you're doing this with older students. So if you can actually use this course 1 with older students, it doesn't necessarily have to be for pre-K.
Exactly.
And you can switch over to the text code to just show them what it's like too.
Absolutely. So and in here I'm going to, we're going to continue, but there is also the show. Oh. Okay, let's do another puzzle. So in this case, it's asking you to jump and draw a square next to the house. So you see the house, our artist is standing right here on the edge, and we want him to jump. So that's one command. And then he needs to draw the square. And we did learn from the last, last exercise that he needs to use 2 of these. What direction would this be? Going forward commands, right? So, right.
And you notice that it actually saves your code. So if you're in middle, if you started working on it and then you log out, you log back in, it saves your code.
It saves your code. So with the problem is with my account, you'll see most of them have the code in there. So you can always move it into the trash bin, and then it becomes a fresh start as well. So I want him to jump. So he's going to jump in this direction. And then I want him to move forward, but how many times? 2 times. And then he goes down again 2 times. And then this way.
And that's course 1 uses this north, south, east, west notation rather than forward, backward, and right and left, which makes the directions like it's not relative directions. It's always, east is always east no matter what direction your character is facing. You'll notice that when you go into course 2 and 3, that's going to change, and you're going to have forwards and lefts and rights. But for this earlier one,
you could use north.
They decided that this is an easier interface because you don't have to worry about which way the character is facing. So west is always west.
So and also as you're transitioning from course 1 to course 2, sort of keeping that in mind that the way these arrows are being used or the direction, the language changes. So sort of introducing vocabulary as they change from course 1 to course 2. So let's see. I could make intentional mistakes in here as an educator. I could change the jump direction, and then it can be a discussion point. But right now, I think the code works. And voila, we got our square. Again, you can see the codes and so on and so forth. So we did a couple of activities using this sort of artist interface in code.org, which will be used in future courses as well. Course 1 is a great introduction to this different types of interface in different courses, like the artist, or you played with the how do we call it, the play lab in here, so that you can see how the blocks move, how the artist works in terms of his movement. So kids are familiarized to that interface, and then they can work with it. So I'm going to close that. And then I'm going to go in here. Let's see. I think we're pretty good with course 1. I'm going to go back to my...
Just one more comment
Yeah,
about
go
course
ahead.
1. You notice that all the blocks in course 1 are fairly image-based, and kids don't really need to read in order to use the blocks. However, the instructions are written, so you need to. So if the kids are already fairly independent readers, they could just take this and do it at their own pace, and just go at their own pace. But if they're not, if they're on the younger end of the spectrum and they're not quite reading yet, then you might have to do a whole group activity and help them through a little bit more.
Right. And especially, as they go through these courses, reading becomes more sort of an activity they have to do because the questions get trickier. And so, again, as Aruna mentioned, maybe as a whole group activity would be a really great way to start. I just wanted to quickly show you one more thing right here, and students will click on this. So we'll talk about Play Lab in a little while, but it sort of allows you to do some apps, maybe not at the level that kids are working with course 1, but they can always play with Play Lab. And this is sort of, they can take a break and they can draw something, and it gives you, I'm going to quickly go in there and show you, they can, they can draw some, they can make the artist draw maybe a different shape or things like that. But right now in course 1, it is trickier for students to sort of navigate the interface that's provided. So sort of staying away from those two might be a bit helpful. Let's go back to, we'll go into course 2. Course 2 is, it's for, it's recommended for beginning readers. So they're reading a little bit, ages 6+. Again, there is no prerequisite for this course, but it is helpful to have worked through course 1 because then they get an idea of the interface, how the characters move, how the artist works. So those concepts are really helpful as they move into course 2. The topics covered during this are more conditionals, algorithm, binary code, even debugging, sort of a little bit more advanced topics than course 1. So we highly recommend going through the sequence that Code.org has given you in terms of like course 1, then moving on to course 2. Let's look at some fun activities. So let's look at the first one, and we have an unplugged activity right here. So let me increase the volume.
This lesson is called Graph Paper Programming, and it's all about algorithms. Today we're going to learn how to write programs that show each other how to recreate simple black and white images using only hand-drawn arrows.
You just fill in square. No, you'd have to go back again and then make it to that spot.
An algorithm is a list of instructions for completing a task. We'll follow this set of instructions to make the bowl. Algorithms, they're really helpful when you need someone else to understand how to do something. If you're writing an algorithm for a computer, you have to break it down into little tiny steps.
So finish this row, then go to the next one, go to the next one, and then you'll be all done.
I use algorithms in my work. If I write down all of the steps, I can recreate that same piece again, or I can teach someone else to do it. Put the glass in the kiln, fuse it together, follow the rest of the instructions to make the bowl. Algorithms give you a roadmap for getting something done.
So you have this really nice resource right here. The PDF will give you access to the materials that are being used in the graph paper programming unplugged activity. So let's quickly go to the next activity. And especially with this activity, it is useful to see this explanation of the unplugged activity, because when we go in here, it gives you a connection to what you were doing with the unplugged activity. And otherwise, if students jump right to this activity, they don't really know what these symbols stand for, and that can be confusing for them. So again, we are looking at the directions. So let's see if this gives you, this means that the square is getting colored completely black. So is this following this? Can this direct or these directions make this image? Which program makes this image? Let's look at this. This definitely doesn't. Let's look at this one. The first one is an arrow, while as we need, you know, we need to make a stamp in here, fill up the square with black color. So obviously this is our choice. It's process of elimination. And then I'm going to submit. I wish I could change. Then comes the matching part, which is really cool because it allows you to look at a little bit more complex problem associated with this. So you're matching multiple. That can be a little bit confusing for kids at the beginning, but then as they go through it, the idea, some strategies are they will literally look at one and try to match it with one of these paths. So let's see, will this match with um, that works. So it's stamping it. Then it's moving forward. So it moved forward. It's moving down. Yes. And then it's again stamping it with the black color. Then it's moving forward. And then it's moving up. And then once it moves up, it's stamping it with the black color. Moves down, and then stamping it. Does that look like a option for us? And they do so on and so forth. Let's look at this. One moves forward, moves down, stamps that. Does not work with this. Now I know if this one does not work with this, I can automatically assume out of the two, this is going to work with this. I really don't even have to check for this. And then the last one remaining can go in. These are just strategies, but it's always very useful to go with, you can cut them out and give it to students and they can match them. So it becomes more of an activity, but you can also talk to them about process of elimination, how one can use these strategies. So I'm going to submit. And obviously, voila, I get the beautiful music. So that's sort of, that was the paper airplanes activity. Oh, how about we just see this activity, it's really great. And we got Megan back here, so we are going to quickly talk about that, and then we'll move on to the next activity.
This lesson is called Real Life Algorithms. Algorithms describe things that people do every day. Cookie recipes and directions for building a birdhouse are all everyday algorithms. Today, we are going to make and create and test an algorithm for a paper airplane. But first, we need to break this big project into easy to follow small steps. For making a paper airplane, we need to decide what steps to take and in what order to take them. You'll create your algorithm by first cutting apart the pictures. Next, you will select the 6 pictures that show the steps needed to make a paper airplane and arrange those pictures in the correct order. After you have everything in order, you will trade algorithms with another student team to test out the algorithm to see if the algorithm works. A well-designed algorithm is super important to making the best paper airplane. When we want to make chocolate, there are many big steps to that process, and each of those big steps has its own set of smaller steps.
Yeah.
This is in
And there are
course 2,
different
the other one was
recipes.
in course 1.
Right.
So if a student is, you're
Missing.
using one or course 1 or course 2 in your class, the student won't be seeing it twice.
Absolutely. So we are going to quickly go to, I'm going to skip some activities because we have, we're looking at our timeline. So I'm going to look at one which is about relay programming, which is right here. And I'm going to look at this. I'm not going to go through the unplugged activity, but again, sort of, I like to point out this particular problem because if you read the question, you'll automatically assume with your previous experience that, what makes this pattern. And then I'll go in, okay, this, and it moves forward and it goes down and then it stamps it and then moves forward, goes down and stamps it. And oh, this works. And I'm going to say submit. And it's going to say incorrect answer. I wonder why. So I'm going to close that and actually read the question. And the question says, which program does not create this image? So it's a not question, which is what I was referring to early, that here the reading aspect of reading the question and sort of understanding what the question is asking is very important. So this one it makes this pattern. Will this make this pattern? So let's say it's moving forward, stamping. It's again moving forward, going down and stamping. So maybe, maybe this does not make it, but let's check just to make sure. Let's check this one. It says it's going to stamp the black color in the square. It's going to move forward, move down, and then stamp again. Then move forward, move down, go ahead and stamp. So let's see, which one do you think is not making the stamp? Oops, sorry. Okay, so well, if I submit this, that's the correct answer, because if I look at this, it is making the solutions, and it will give you sort of the next, which is a multiple choice with multiple questions and choices. And again, it goes in the incremental levels of difficulty. So that was one that I sort of wanted to show you specifically for the purposes of, looking at and reading the questions. The one I wanted to quickly show you, let me go back and show you a lesson plan for this so that you can see, where did it go? I go to the home. Okay, so let's look at, I'm hoping to go to B debugging. Let's see. Okay, B debugging. And in this case, I'm going to go in here. I'm going to view the lesson plan so that you can see that they really make an effort of letting you know how you can introduce it, what is the activity, what are the student learning outcomes that you're looking at, what are the objectives, and then the connections to the standards. And this is really great because you have PARC assessments, you have ISTE, which is formerly NETS, you have the CSTA K-12 standards. Now, these are national standards, as I mentioned before, and they also very well align with the MADLCS standards. So, you have these really great alignments with CSTA and then the science and Common Core mathematical standards. So let's go back to the activity. We are going to do activity 5, I believe. Yes. And if you see the difference in the two, it shows that this one is perfectly completed, but this one, which is 6, is sort of like a light circle. So it shows that it's in progress. So we are going to quickly go through this, see what it means. It says the flower looks tasty. Fix the errors to collect all the nectar. You can now use both run and step. Okay. Well, there's a program in here, and they're asking me to fix the errors in the program. Well, it's sort of asking me to fix the errors, but let's see what the program does. When I run the program, I am repeating the loop 4 times, which means I'm moving forward 4 times. Let's say 1, 2, 3, and 4. And then when I get to the flower, I'm going to get the nectar. It kind of looks okay to me, but it's a great discussion point with students. That is this a tricky question? Is it asking you to really look at a program that is correct, or do you need to make changes? And students might play with this. They might move the block and add different blocks. And prior to this, as you can see, there is a loop that we are including in this activity. They will have gone through activities that allows them to sort of use this block in programming. So we are going to run it. They have really fun. Yummy. Okay. And now comes to the 6th part of that activity, which was the challenge that I did not complete. So it's asking me to, what is sweet challenge? Fix the errors to collect all of the nectar. So it's asking me to, let's see.
And you notice how now it's doing forwards and left and right. So now
Right.
you have to worry about which way the bee is facing.
Right.
We're no longer doing the north, south, west, east.
Right. That's why the vocabulary aspect of it is very important, because sometimes, just knowing what is forward for the bee is how their programming is going to look like. So let's look at, the bee needs to move how many blocks? 1, 2, 3. Do I have 3 forwards here? No. So let's try to put that in. And then I need to turn left, or do I need to turn right? Looks like I need to turn right. In here, you can always change. We are turning right. And then I need 1, 2, 3, 4, 5. So it looks like if this was 6 times, which sometimes, 1, 2, 3, 4, 5, and 6, which is what students sometimes count, which is another error that we've seen happen. It sort of just tells you what the student is thinking in terms of his programming. He's literally counting the squares, and since the B is starting from here, he expects the B to go 6 units forward and then get the nectar. Let's run this if that's true, and it's going to give us. It really doesn't give you a hint in terms of what possibly went wrong, but that's another opportunity to have that discussion with the students. So again, we know in this case it was, it could possibly be this, but then students literally go through each block of the code. You can go through the code with them and see where is the B landing as they are moving through the code. We're going to reset it, we're going to run it. What is that sound? Okay. It's wonderful. So essentially, they're learning the strategy of debugging, what it means, going back to the code, reverse engineering the code to see how specifically, the algorithm that they've constructed is working.
Oh, wait.
Oh, go ahead.
So in that little window that Rashmi just closed, it said that you did it correctly, but you could have done it with fewer lines of code.
Right.
So there's multiple ways to finish each project. There are multiple paths to the correct answer, but sometimes they do encourage you to try to do it with the least amount of code. And in this case, you could have consolidated those move forwards with a loop and made it a little bit shorter.
Absolutely. So that is one of the learning moments for you, because as students are progressing through these courses, they're going to see these sequences. This is exactly how they've been constructing code. So using more of this and sort of introducing this idea of condensed code that does the same or implements the same algorithm is something that students work through in time, and sort of Code.org helps you in negotiating that. So what we could do essentially is take this out.
This is where all the practice you have with the puzzle comes in handy. How to peel away these codes.
Right. And students still may have, it takes them time to move the code. They might lose certain things. So sort of having that patience and again, what do you do with this block? So it's important. Actually, let's keep it here and see what happens if you leave the rest of the code snippets, as I call it, out here. And is it doing what I'm asking it to do? It's moving 3 blocks. Let's see if it's, yep. And then it's turning right and then doing that. Yep. Right, so it gives you this nice little warning. You have unattached blocks. Did you mean to attach these to the run block, or what do we do with this? So it's important that you clean up your, the coding interface, because it's going to run or try to run all the commands that are put in here. Reset, and it's going to run. It's going to run instead of. Right. And then you just write 6 lines, and it's nicely done, and it will give you that nice check mark, which is a dark green, into your sort of. I'm going to stop this quickly, otherwise it'll keep on going to the next section. Okay, so we are going to go into, let me close that. That was your debugging. And we are going to go into course 3. Which is essentially designed for students who have taken course 2. It is recommended for students ages 8+, and again, recommended highly to complete course 2, which is a prerequisite, and this course addresses topics such as problem decomposition, functions, nested loops, conditionals, and sort of, overall concepts of digital citizenships and internet safety as well. So let's look at this. How much time do we have? Let's look at one. Yeah, let's look at the unplugged activity quickly, and then we'll breeze through we'll just do one more activity because this is a
This lesson is computational thinking. Sometimes learning a new game can be tough, right? At first it might seem really confusing, and sometimes there's no one there to teach you the rules, so you have to figure it out on your own. The good news is that you can get better at figuring out things on your own when you know a few thinking tricks. These tricks are unique ways for looking at and solving problems. In this lesson, you'll learn about 4 tricks and practice them with your friends to figure out the rules to a game. When you break down a big problem into smaller pieces, you're using your brain to decompose the big problem. Once we've decomposed the big problem into several smaller problems, we can go on to our next trick, which is called pattern match. And that's when we look for similarities between things. Once I find the things that are the same, I can figure out what things are different. And when I remove those differences, that's called abstraction. And after I have figured out the steps to solving a problem, I can put those steps in a specific order called an algorithm so that anyone can use my directions to solve that problem. We're going to use these 4 steps to figure out how to play the game with no rules. So by the end of the game, you'll be able to play something and get something that looks like this.
Oh, wow. So that's a nice little introduction to computational thinking. You can do one quick activity in here, and then we're going to move on to course 4. Here, this is again, the students are reading, so you're looking at, here are 3 sentences, which are the templates below correctly abstract so that all 3 matches the same pattern as the template. Seattle is a big city, so does it fit in here? Seattle is a big city, blah, 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 fits in here, but it is not applicable to Eugene or Hillview, so that's gone. Eugene is a blank city, does not fit in with Hillview and Seattle, so then I'm going to look at this option, which is blank is a blank city, and you can see that blank, Seattle can be a blank, is a blank city. So it goes in with every sentence that is given, so we choose that. So sort of sometimes doing these activities with your students and sort of letting them know how you're thinking about it is also very helpful. It's a great strategy to use with your students as you are uncovering these challenges. We are quickly going to move on to, there are really cool activities in course 3 and 4, but with respect to time, we are struggling, so we are going to give you a taste of course 4 quickly. You're going to look at the Maze and B lesson plan. I believe that's one. I wanted to also show you the lesson plan, but let's see if we can. Avoid the TNT, that's the only task. Okay, so I'm going to put that in here. This is my Angry Bird, and I need to avoid this TNT right here, and then he can go and meet with this Green Goblin or whatever he's got. So let's look at, I'm going to move forward 1, 2, then I need to turn left, and then I need to move 1, 2, and then I need to turn right. So let's do, I'm going to do step by step. So he moves 1, then he moves another step. I cannot do, as you can see in here, you do not have any loops option. So many a times the activities will start like this, where they don't really give you the option of condensing the code. And that's okay, because students have that concept building up in their head, and when they see those options, they will implement them in the program. So let's see, now he's right here, and he needs to turn left. So he's turning left, and then he's moving forward, I hope, about 2. Then he turns right, and then he's going to move forward. Let's see if that's correct. Uh-oh, something went wrong. I wonder what. So this is a common mistake with this first activity that students do. They think it's 2 moves, as opposed to one move. So, as they're debugging through this code, they will recognize that it's only one move, and then he's turning left, and then it's one move. Let's see what it does. And again, if I keep this code right here, let's see. Again, we ran into the same problem. So we are going to make sure that he's just moving forward once, then turning, and then moving forward. And I'm not going to keep this in here because that causes problem. This kind of intentional mistakes in there will really allow your students to think about what you are doing if you're doing this as a group activity with them, and sort of debugging through that code. Really, that is a really important skill. So again, okay, so we did one activity, and you can go on and complete many different challenges. I had B for loops and artist variables, which were really cool challenges. So if you have time at the end, we'll come back to it. But right now, we're going to stop. Oh, wait. Okay. Let me go back to our presentation so that we can get back to looking at our courses.
While you're doing that, Brian had a good question. He is asking whether we can assign different activities to different students, which the answer is no. You cannot assign a specific task to a student. They're going to get the whole menu, the entire table of contents. However, they can skip around. So if you feel like that student doesn't necessarily have to do the first chapter or first lesson and can move on to the next one, that's totally okay.
Absolutely. Thank you. Thank you, Brian. So we looked at the elementary course, CS Fundamentals course review. It's right here, and we are going to also put the link of this course structure and curriculum connections into BPS Learn so that you can get to it very quickly. Okay, I'm quickly going to go through that. Play Lab. I wanted to show you what Play Lab is, but if you have, give me 1 second, we were right here. Play Lab, I'll quickly explain this. This is sort of like a place where you can create some apps, fun apps, and they have options in terms of programming those apps. And you can choose your Play Lab theme. Depending on the theme, the characters, you can program those characters accordingly. And this was a great challenge for Hour of Code. It was quite liked by students as they did these in the classrooms. So you can do an hour-long activity, or you can go through the whole curriculum for Play Lab as well. Middle school. So we looked at elementary courses. We're going to quickly look at middle school courses. And give me a quick second. I'm going to shift to the, what happened here? Okay. Okay. Yes, so there is a CS in Algebra course, which is Codeorg has partnered with Bootstrap to develop a curriculum which teaches algebraic coding techniques, teaches algebraic and geometric concepts through computer programming. The 20 lessons that are in here focus on concepts like orders of operation, the Cartesian coordinates, function composition, definition. So this can be really integrated into an algebra course, and also aligns well with CS concepts. There is a teacher manual, student workbook, course overview, and standards alignment right here. What is cool about this course also is there's a video selection of, talking about how teachers have implemented this course in their classroom. So these are great ideas. I was going to show you the orders of operation video, but I think obviously it's right here and you should be able to see this. You can download these videos so you can play them in the classroom just in case you don't have specific, really good internet connection. They're downloadable and you can watch them. So again, there is a whole selection of these videos of implementations in classroom. But there is a curriculum progression in terms of Course A and Course B and specific topics that are addressed with these courses, so keeping that in mind.
But this is separate from the Code Studio, which was the tutorials that we just went through the course
Right.
before. This is a separate curriculum from that.
Code.org.
Yes.
And we are going to give you sort of in the semblance of elementary, middle, and high school, what is available from Code.org in terms of curriculums that are aligned with the standards as well. So the second one is CS, middle school computer science course in science, and this collaborates with Project GUTS. They use a modeling simulation software called Star Logo Nova. Some of you, especially BPS teachers, have already used this in their classroom. So it's a great sort of modeling tool that allows you to see exponential. You have 4 modules in here talking about simulations, complex systems, chemical reactions. So it's a nice way in which you can integrate it into the science classroom and also talk about computational thinking, CS, skill sets. The last one I wanted to quickly mention is the CS Discoveries course. CS Discoveries is designed from ground up. It's still in the process of getting designed, but it's an engaging course which allows for, the course overview has 6 units which focus on these specific topics: problem solving, the internet, programming, interactive games and animations. Again, they also talk about the design process, the programming sort of from the HTML and going forward. This course was piloted with the perspective that, the pilot teachers are looking at it from a makerspace perspective as well, so that they can get students physically engaged in making artifacts and sort of engaging with the curriculum that way. This course, Code.org, is going to use to promote as a course prior to CS Principles course, which is now APCS Principles course from Code.org. This is a great course which is designed to fit naturally between the CS Fundamentals course, which is the elementary course that you looked at, and this fits right in the middle. This can be offered at the middle, upper middle, or lower high school level, and can serve as like an introductory course. So, and as you can see in the frequently asked questions, there are a lot of questions about what is the relationship between ECS and CS Discoveries. And why is Code.org transitioning to the new course in ECS? They are highly recommending CS Discoveries because of the integration of AppLab programming environment, which allows students to see the block-based code as well as the JavaScript, and so students are sort of looking at different types of programming modules and activities. And what is the timeline? So you can look through that to get more information about the course. Let me quickly switch to our high school, and that will be here. Those are our middle school options. We just looked at our computer science discoveries course. And again, this transition to CS Discoveries from ECS will happen next year. But Code.org also supports ECS, so they will make the version 6, I believe, curriculum for ECS available, but they are also promoting CS Discoveries. For high school, currently there is Exploring Computer Science course, and we've talked about it in the ECS webinar. And there is a website, and Code.org also connects to that. But there is the AP Computer Science Principles course, which was AP approved. Give me a quick second. Which was AP approved recently. So let me quickly go to that. This is your AP Computer Science Principles landing page for Code.org. It talks about APCS Principles course, but sort of recognizing that it is a rigorous course. It gives you this syllabus, which is the 2016-17 AP CSP endorsed syllabus. So if you look at the syllabus, it will give you an idea of let me quickly go to that, and we might be able to open it quickly. So it gives you, it's like a full year rigorous course that introduces high school students to the foundations. This course snapshot is in 5 units, but there is also a 6th unit, which is about, the performance tasks. April is usually the timeline for AP's performance task submissions, and May is when the exams happen. So this is a really great space to find materials for Code.org's Computer Science Principles course. What I wanted to quickly show you as well is every unit in APCS Principles. Let me go back to that page, because being in here, it gives you access to videos, it gives you access to sort of the one-pager, what professional development offerings are available to you. You can take a look at that. But what it also gives you is link to units, and what a unit level looks like is right here. So when you click on that, you can see each chapter and what the weekly plan would look like. And when you click on these specific lessons, you would go into the lesson setup, which is really great because it gives you step-by-step teaching tips, resources, sort of the agenda for the lesson, and alignment with the CSTA. So you can see that they're aligning really well with the CSTA principles, and helping you with, specific videos maybe, or resources that are required. What I love about this is they also have assessment questions and extended learning built into this, so you could use that as your formative assessments as you go in with your students. And again, standards alignments with Code.org is always with CSTA K-12, because those are the national standards. That's Haruna's phone. Okay, so these are a quick overview of your units. App Lab, I wanted to show you what App Lab is, but I think we'll quickly go to the App Lab, because I believe it's in here. Just as it's a great resource to. Okay, so yeah, this is your App Lab right here. Okay, it actually went in for me. App Lab. Okay, give me a quick second. It's coming up. So App Lab is a nice little programming environment where you can make simple apps, design an app, code with blocks or JavaScript as it works through it. They have a nice little tutorial right here. It's a 7-minute tutorial which gives you a very detailed introduction to what App Lab looks like. And as you can see right here, you have code and design menu. So if some of you have worked with Dreamweaver, you used to always have this menu where you could actually see the code, and then you could see the design interface of it. So that's a really great way of looking at it in terms of the JavaScript that's embedded in there. This video here, I really love it because it's a student example of how they've constructed their app in App Lab, and it's a very detailed example. So I highly recommend you watch this before you sort of look at App Lab, and we'll try to do maybe a session with App Lab in fall, just to see how things go. There is also deeper dive into App Lab, and you can see, there are certain interface questions that people have asked, and they have addressed those in that. And these are sort of videos these are really great videos because they talk about specific concepts in CS. They're not just related to App Lab. They are very universal. What is function? What is procedures? And people are talking about different concepts, variable as a container, talking about Boolean expressions and stuff like that. So you can integrate these regardless of whether you're using App Lab or not. So let me quickly get back to the last bit for our presentation. Where are we? Where did we go, Haruna? Where did it go? Okay, we're right here. Okay, so again, these are the resources. There are a few more courses which are Accelerated Intro to CS course, which combines the course 1 and 2 that you've seen.
2 and 4, 2, 3, 4.
Sorry,
Yeah.
You can check out courses 2, 4 for more complete
Yes,
experiences.
so it combines 2,
2, 3,
yeah.
and 4. Yes.
2, 1. Class.
Right. And the Fundamentals Unplugged is also going to give you a list of unplugged activities that you can implement. Again, these are resources, great resources that you can integrate in your existing curriculum as well. Last but not the least, we have Digital Backpack, where if you can see that is code.org, and you can log in.
Yes, so Digital Backpack is part of a tool that we use in BPS. If you go into the OIIT's website at bostonpublicschools.org/technology and then click on Digital Backpack, you will get this page. And if you go into code.org through here and log in with your BPS credentials, it'll pull out your student roster from SIS. So you won't have to create all the student accounts yourself. It's all going to be synced. So next year, when you have your student rosters, if you go in through the backpack, it will save you a lot of time in creating your class list.
Right. And again, you can even type Digital Backpack in your Google, and you get that pretty much. So sometimes if you cannot find it, you can access it through that.
For now, when you're testing it out for the purpose of this class, you can just log in normally. But next year, when you're using it with students, we suggest you go through the Digital Backpack.
Right. And we believe that there's going to be a tutorial about how to use Clever. But yeah, once it's announced, you'll know about it. Again, standards, alignments to CSTA K-12 computer science standards. These are the 2 strands: computational thinking, computing practice, and programming. ISTE standards. Everything that these courses use is aligned to these standards. MADLCS standards just came out June 18th, I believe. So we have these 4 strands. These are inherited from CSTA standards as well. They are very well connected. So things that are aligned with CSTA will automatically align to MADLCS standards. So it's a great conversation to have in terms of, what are the learning objectives for your classroom. Assignments, yay! We have 3 assignments for this session. The exit ticket, you'll complete right after the session. We have the homework activity, which is linked right in here. That's the homework activity. And then you have the Code Studio course activities. What we are asking you to do, we were hoping you would go ahead and complete like a course and send us the certificate. But again, being mindful of your time, we are just asking you to complete 2 activities and possibly take screenshots of those activities, which means 2 from course 1, 2 from course 2, 3, and 4. So you'll have total of 8 activities. You can pull them together in a Google slide, and you can send us the link, or you can also link it in BPS Learns. The optional is, of course, and our highest recommendation is, it's addictive. So go in, complete a course, complete 4 courses, go through them.
The accelerated course might be a good option for that, because it condenses 2, 3, and 4 into one class, and you'll get a taste of everything.
Right. Absolutely. It gives you a perspective of what your students are going through. So it also helps you navigate through the activities as they are navigating through them. Recommendations, I think more than any other recommendations, we want to focus on, going deep conceptually with whatever tool you're using, and not focusing so much on different types of tools, but rather focusing on the concepts that you're learning from the tools, because concepts do stay with you. The tools can change, and they usually change with time. So concepts of functions, variables, algorithms, loops, those are the concepts that you're hoping your students gain from any of the tools you're using. Last but not the least, next session is a fun session about introduction to Scratch Junior.
Scratch Junior is an app that works on iPads and Android and Chromebooks that is specifically for younger children. So if you teach kindergartners and 1st and 2nd graders, this would be a good session for you.
Perfect. It's a great app, regardless. And last but not least, we're going to talk about, we talk about this every session. It's the Learn, Teach, Lead conference. It's a BPS Digital Learning Summit. We do not have more information about it, but it's happening on Wednesday, August 10th at Boston Latin School. There is link to the website. So do go there, and the updates are posted over there. Thank you so much, and happy computing.
All right, see you next week.
See you next week. Thank you. Una.